this lesson is about okay, two little things I'm going to mention before I explain how the air conditioner is going to work. One, and you should already know this, but write it down anyway. When pressure in a gas goes up, what happens? What happens to temperature? Goes up.
Yep.
And if pressure goes down, temperature goes down.
May I have your attention at this time? We are in a shelter in place. Shelter in place. At this time, shelter in place.
Nowhere. Just don't go in the hallway.
Shelter.
Shelter in place means don't go in the
No,
hallway.
we're talking about, I said it, shelter. He said shelter, he didn't say shelter.
Alright, alright. So, you guys remember from last week, the day that I passed this around, right? Pressure goes down, temperature goes down, right? If I was to pump air back into this, it would get hot again. Alright, other thing I want you to know before I talk about the air conditioner, if pressure goes down, so does boiling point. And I don't think I mentioned this yet, so that's why I'm throwing it in here. Actually, the day we watched that video on space and liquids, they said if you're out in space, there's no pressure. Water will boil at minus 450 degrees Fahrenheit.
Yeah.
Right? So as pressure goes up, boiling point goes up. Pressure goes down, boiling point goes down. All right, so these two things are important to how the air conditioner works. So now we're actually going to draw the air conditioner. And we'll start at the bottom here. And, well, actually, we'll start like this. This will be the wall, this dotted line. So imagine, right, the air conditioner goes in the window. This is outside. This is inside. That's how it has to be, right? This kind of air conditioner, if it's sitting inside the house, it's not going to work because there has to be part of it that's outside to give off heat. Okay, so the way I have it set up, so the left side is going to be outside. The right side is going to be inside. And we'll start by drawing a drawing. All right, so we'll start with a compressor. So the compressor is at the bottom. And sadly, the way I draw it is the reverse of the way I have this thing. Because for me to show you the compressor, it's right here. It's this big thing here. Okay, but I wanted it to face this way because the way I typed the worksheet, the left side is outside and the right side is inside for you guys. Anyway, so here's the compressor, and then off the compressor, and if you have colored pencils, now's a good time to use them. You have coils going outside of the house. And a coil is just a tube that has fluid inside of it. Okay. And so on this particular thing, these copper tubes here, these are the coils that I'm talking about. And there's fluid that goes through these tubes. And I drew them in red on this thing because they're the hot side. Okay. And then you have a little tiny thing at the top that's basically like a funnel. It starts out thin, and then it gets wide. And this piece here is called the expansion valve. Expansion valve. And then on the other side, you have thicker tubes coming out of here. So I guess I'll make them like that so they're thicker. You can just make thicker lines. Again, copper tubes going back and forth, over and over.
At this time, you can resume regular activities. At this time, please resume regular activities.
All right, so that is our air conditioner. We have a compressor, and we have tubes on the outside, we have an expansion valve, we have tubes on the inside. So this is inside of your house, outside of your house. These are the outside tubes, the red ones, and these are the inside tubes, the blue ones. And the expansion valve is in here somewhere. It's this tiny little thing. Okay, so how does this work? I'm going to have to erase here. Does everybody have this written already?
Yeah.
All right. So what you need to be thinking to yourself, and understand, an air conditioner is a pretty advanced thing. We only invented them in like the 30s or 40s or something. So it required a lot of technology. The idea was, how are we going to give off heat to the outside, right? How are we going to take heat out of the house and give it off to the outside when it's hot outside? And how do you do that? Well, you got to make something hotter than the outside to give off heat to the outside. Okay, so that's why we have this compressor. So step one, a little one here. Okay. So one is compressor compresses compresses fluid in the air conditioner. And what happens when you compress it? Fluid gets hot. So there's, this old one probably would have had Freon in it, still does, and so compresses that Freon, it gets hot, and then it comes out of the the compressor in this direction and goes into these tubes here. Okay. Two hot fluid goes through tubes. So that'll be like over here. Hot fluid is going through these red tubes. And that's these copper tubes on this side. It's just going back and forth. And the reason it goes back and forth a whole bunch of times is there's a lot of time to give off heat. There's a fan here. And we'll add that in. Fan blows outside air, outside of the house, outside air over hot tubes. Understand that the outside air and the inside air are completely separate and don't mix. And you can see this fan. The fan is like right inside of here. Okay? So what happens is it's taking air from the outside, okay, blowing it over the tubes back outside. So this is all happening outside of the house. You have, 95, 100 degree air because it's summertime. But these tubes are going to be much hotter than that, 200, 300 degrees, because the air is compressed in here. And since they're hotter than the air outside, they're able to give off heat to the outside. So fluid or tubes give off heat. And this step is really the genius of the air conditioner. It's that you compress the fluid, it gets hot, and so you're able to give off heat to the outside, even though it's hot outside, because you make the fluid hotter than that. Okay. Also, while we're here, 3, fluid condenses. It's under pressure, so the boiling point is much higher, so it condenses from liquid to gas. So you remember I spent a whole day talking about heat of vaporization and how much heat it takes to turn a liquid to a gas. Well, it also goes backwards. How much heat do you have to take out of something to turn a gas to a liquid? Well, that's how much heat is being given off here. So you're cooling the gas, and then you're condensing it to a liquid. 2 times heat are being given off outside. Okay, so here's the hottest point, right? Right there is the hottest point. And then as the fluid goes back and forth, it's getting cooled and it's condensing, both times giving off heat to the outside. All right. 4. Okay, I did that already. So let's do liquid goes G-O-E-S, goes that's up here at the top. This is 4. All right, so down here we got really hot fluid. It's compressed under high pressure. It cools down somewhat, so maybe let's say it's 200 degrees here. Maybe by the time it gets up here, it's down to 150 or something. It condenses to a liquid. It goes through this expansion valve. So it goes from a tiny tube to a much bigger tube. The liquid is expanding, right? What happens when it expands?
It gets cold.
Come on now. Cold. It gets really cold when it goes from a small space to a big space, right?
Yeah.
So fluid gets very cold. Okay. So now we'll move over here. All right, so here it gets really cold. So we have a cold liquid, and it's, remember, it's flowing this way now, right? This direction, this direction. So we have this cold liquid coming into here, and as it comes into here, there's a fan over here on the inside of the house, separate fan, separate air. This blows inside air over top of the cold coils. So 5, fan blows inside air over cold coils. Now this is what you got to understand. When the fluid came into the compressor, it was room temperature. It went through all this stuff, gave off some heat, comes through the expansion valve. Now the pressure is the same as it was at the beginning, except it gave off some heat, so now it's even colder than it was to start. Now it's really cold, right? 30, 40 degrees, something like that Fahrenheit. Very cold. So the fan blows cold air over the coils, right there, right? And what does that do? Cools the room, which is the whole point of the air conditioner. And then as we go through this, so we'll put like 5 and 6. Fluid heats up, and so as it's heating up, it's taking heat out of the room, right? It's cooling the room, which is the whole point, and flashes to a gas. Goes back from liquid to a gas as it's being heated. Now, as the freon in these tubes goes from a liquid to a gas, what do you need to turn a liquid into a gas? Heat. You need energy. And where's that heat coming from? It's coming out of the house. It's taking the heat out of the house. So again, twice it's taking heat out of the house. As it's being warmed up and as it flashes from liquid to a gas, both of those require heat. That heat's coming out of the house. And then the cycle starts again. So when we get down to here, it's warmed up. So this is the coldest point right here, right? This is where it's really cold. You can't see. So it's really cold, goes through here, cools down the air, freon warms up, comes back to here, you compress it, it gets really hot, goes through here, you blow outside air over it, takes some heat out of it, drop the pressure again, it gets really cold, cools the inside of the house, and the cycle just repeats itself over and over. So because it's under pressure out here, it's really hot and it gives off heat. Because it's a low pressure in here, it takes heat out of the house because it's really cold. Make sense? Questions? Everybody got it? All right. I think we're done. I'll give you guys the practice test on Wednesday.
Yeah, lab Wednesday.
I don't know. Today's day D, so. Okay, yeah, so Wednesday.
Today's day D.
Today's D.
Yeah.
That's what I've been told.
Oh, sorry. Oh, sorry.
Oh, can you shut the camera off?
I'm thinking of last year because we had lab D.
Hey, Dimitri, you're killing me with these elements, man.
Oh, no. They're not killing you. They're wonderful. Hey, can you shut the thing
Oh,
off?
yeah.
Thank you. Yeah, you're going to love that chart. When you go to college and you take chemistry and you're like, oh, wow, I know all these elements. You'll be so happy. You'll be writing